function r is given, and which of the following describes the equivalent form of the function r and the corresponding asymptotic behavior. So this asymptotic behavior is going to describe how the function behaves as it approaches the limit. Not necessarily reaches it, but as it approaches a limit. So when I look here and I look down below, I can see that they've gone ahead. And what they're doing is when we think about our end behavior, remember, we have to look at what is the degree in the numerator and what is the degree in the denominator. So this is going to mimic what we just did in question number 3 of this same task. So when I look here, notice I have a degree 3 on top and I have a degree 1 on the bottom. And so what I'm going to need to do is I'm going to need to go ahead and do polynomial long division. Your numerator is going to go on the inside. Everything needs to be accounted for. So this is to the third power, to the second power, to the third power, and last and up front to the first power and to the 0 power. As a reminder, how do we do this? X times what quantity equals 3x cubed. So 1 times 3 is 3. I need a total of 3 x's. I need to attach 2 more. This is what goes up above. Now I'm going to multiply to get 3x cubed minus 3x squared, changing the sign of everything on the second level, and then adding straight down. Let's do it again. X times what quantity is 3x squared. 1 times 3 is 3, and x times x is x squared. So 3x plus 3x. Again, I'm going to multiply. 3 times 1 is 3 with an x squared. 3x times negative 1 is negative 3x. Change the signs and add straight down. I'm bringing down the very last number. X times what quantity is 5x. 1x times 5. 1x times 5. And I'm multiplying, changing the sign, and adding straight down. Now, we do have a remainder of 4, so how do I write this? Because this is going to describe the slant asymptote. So the function r of x is going to get closer and closer to the slant asymptote as it moves to the right without bound and to the left without bound. So here's going to be the equation of the slant asymptote. It's going to be 3x squared plus 3x plus 5, plus we have a remainder. I'm going to do plus because this number down below is positive. That remainder always goes on top, and out front would be the denominator of the original function. Okay, now let's look at our choices. And remember, we're looking for what first can I cancel out? And I can see that I can cancel out option C and option D. And so I'm looking at the first 2 options. We know this graph is going to get closer and closer to the slant asymptote as it moves to the right and the left without bound. So the graph of the function r is going to get arbitrarily closer to this as it increases without bound. That is the correct answer. It does not get closer and closer to this remainder. That's what option B said. It does not get closer and closer to remainder. It's going to get closer and closer to this entire equation that describes the slant asymptote.